Hey everyone, so I want to talk about this Discovery Channel laser curvature test that was done recently. Stephen Hawking somewhat hosts the show, and 3 people went out and did this test on a lake. John Cena, wrestler, was one of them. I don't know the other 2 women. They may be famous people, I have no idea who they are. But anyway, it was a pretty simple test. What they did was they put a laser on the beach and had a boat 3 miles away from it and shined that laser over the surface of the lake.
Joy to boat.
This is Kat, over.
I want you to go at the front of the laser.
Roger. Now we're gonna turn a little to the right.
If the lake is flat, the laser beam and the water will always be parallel to each other.
Almost there. Here we go.
They take their first reading 500 feet from the shore.
Okay, that was the height of it. Got it.
For the next measurement, they'll need to go much further out.
Okay, so now I need to go 3 miles away from the laser.
So 3 miles away, where is the laser beam? Remember, if the lake is flat, it would be the same height as before.
And the laser hit 6 feet above where it hit, where they tested close to shore, where they were 500 feet from the laser. And then it was about 6 foot difference, about 3 miles away, which is what they would expect to find on a sphere with a circumference of roughly 25,000 miles, or a radius of 3,959 miles, which we use to get the 8 inches per mile squared.
A little bit more to the right.
Here we go.
I don't even think this beam is gonna hit our boat. So we're gonna have to measure it on something else. All right.
No idea. Considerably
Here we
higher.
go.
Is that your measuring tool?
Do you see it?
Yep.
Can you mark it?
Just 3 miles away, the laser seems to have risen by 6 feet. But we know the beam is level, so that suggests that the lake is now 6 feet lower.
To see a 6-foot drop when everything looked flat to me was kind of mind-boggling. Definitely kind of shattered my perspective in about 1 second. It made me rethink what was going on. Perception is still it's a flat lake, but
So it's not a flat lake.
it's not a flat lake.
And so it made it look, it looked like it proved that the Earth is a sphere. But they never showed how they leveled the laser. And so if you assume a flat Earth, which is what I have drawn here, the water line is level. So therefore the laser line must be level, because if it's not, it'll show something different. It'll show a change in the difference between the water line and the laser line at the beginning and out here where where you hit the target. And so you can figure that out pretty easily, because your level line, would be the length of this leg of a triangle would be 3 miles. I've got 500 feet to point A where they take their first measurement, and then the rest of 3 miles, which is 15,340 feet. And we got 3 miles up here, and that's where they had their target. So you could, if you wanted, if you did this on a flat Earth and you had 6 feet here and say 0 here just at the beginning. I mean, point A is actually at 500 feet in front of the laser level, but we're just saying that that's at the point here on the triangle. This point here on the triangle that I've got drawn over here, A would be the 3 miles. You could figure out what this angle is easily using simple trigonometry. So you take the opposite leg B here, the opposite height of the triangle, divided by the distance, leg A here, opposite over adjacent, inverse tangent, theta, this angle here, theta, is equal to the inverse tangent of 6 feet divided by 15,840 feet, gives you 0.022 degrees. That's a very, very small angle. And if you were standing on the beach looking at this laser, you would not be able to tell that it's not level if this is the case. And so if the Earth is flat, you could go out, say, with a target on a boat or something and be about 3 miles away from your laser and have it hit the target 6 feet up and drive back and see, you know how high the laser is off the shore. So you could put the target up a certain height above the water line and then drive back, and you'll see that you're about 3 miles away. You're 6 feet higher than you were when you take it up near the shore where the level is. I'm making accusations. I'm not saying they did that, but it is possible. It's very simple. So to do this, you would actually need to, of course, level the laser, but assuming they did that, you still need a second laser. To do an experiment like this, I think we need 2 lasers, because you put them side by side and level them both, whatever method you use to level them, to make them so they would be parallel to the surface of the water if the Earth is flat, because you must do that to do this test, regardless of what the shape actually is, and have both lasers leveled, and then have a target, and if the lasers hit that target at the same elevation or the same change between the starting elevation and the ending elevation, then you can assume that they're both level, or it's safer to assume that. It's kind of a control, and they didn't do that, but watching this thinking about this has made me want to use 2 lasers for a first test for a force-align experiment, which is similar. And I'll get into that in another video. If you're familiar with force-align, you may see where I'm going with this, using lasers to force the line instead of actually building that, and just build a level line, which theoretically would be curved if the surface of the Earth is curved. So that's what I think about this test they did. I mean, they could have leveled it, and the Earth could be curved, but they didn't show that. And I think you definitely need another laser to verify and have them both hitting at the same height, and both leveled and shown how it was done. And this is a very small angle, as mentioned, or as calculated. So that's it. I think we can go further with lasers. But Discovery said this was a test that was adequate, and I think we need to refine it a little more and eliminate some variables. And that's just my opinion. So until next time, peace.